Hello learners, welcome once again to our today's mathematics lesson. The topic is mass, weight and density. In our previous lessons we looked at mass. In our last lesson we were on weight and we defined weight here, and then I did a few illustrations, examples on the board on how to calculate weight. Then I gave you assignment, which it's my hope that the assignment is done. If it is not done, please go and do the assignment, then come and proceed with the lesson. Once again, the topic is mass, weight, and density. Mass, weight, and density. The subtopic is weight. The subtopic is weight. Learners, we defined weight. We also defined mass. We say that mass is simply the quantity of matter in a body or a substance or an object. Mass is the quantity of matter that is contained in a body or a substance or an object. And mass, we said, can be measured in kilograms. Kilograms is the SI unit of mass. But we say that there are other units that can be used to measure mass, for example, grams and so on. And weight, we defined weight as a gravitational force that is exerted upon an object by the earth. All right? We said that weight is that force or that pull exerted on an object towards the earth's center, the center of the earth. We say that weight, if you remember, weight is the gravitational force exerted on a body by the earth. And we say that every object on the earth is pulled towards the center of the earth. That's what we said last time, that every substance on the earth is pulled towards the center of the earth by a force known as gravitational force, or what we call the force of gravity. The force of gravity. Now, the force of gravity on an object is what is referred to as weight. That's what we said in our last lesson, that the force of gravity on an object is called weight. So force is a weight, okay? Or in other words, weight is a force, okay? Force of gravity on an object. I gave an example of my objects. I gave an example of an object. This is an object. If I was to drop this object, not throwing it, but just leaving it without exerting any force, this pen will find its way towards the center of the earth. So the question is, what makes this pen drop down towards the center of the earth? The force that brings this pen towards the center of the earth is what we are calling the force of gravity. So learners, let me now surrender the pen to the force of gravity. The pen has been surrendered to the force of gravity, and because of that force, that pull, the pen has been pulled towards the center of the earth. We said every substance on earth is pulled towards the center of the earth by a force which is known as the force of gravity. So the force of gravity on an object is called weight. And the weight, this weight, we said is measured in newtons. The SI unit of weight is Newton, abbreviated as N. Weight is measured in newtons. And remember, learners, we also said that weight is not constant. Weight is not constant, but mass is constant. Very important distinction between weight and mass is that weight is not constant, but mass is constant. Weight is not constant, but mass is constant. We said that the mass of an object, is constant, but the weight of an object is not constant. The mass of an object is constant. That means it does not change regardless of where you are. That is the mass. Okay? Then the weight of an object, depends on two things. One, the position of the object relative to the center of the earth. The weight of an object will depend on the position of that object relevant to the center of the earth, such that the farther you get away from the center of the earth, the less weightier the object will be. An object will weigh less. For example, if it is at the sea level as compared to when the object is on the top of the mountain, because of the position. Okay? The top of the mountain is far away from the center of the earth compared to the sea level. All right? And an object will weigh 6 times less on the moon compared to the position of the same object on the earth. If you have an object, it will weigh 6 times less, all right? 6 times less on the moon compared to the same position of the object on the earth. So the position of the object, the weight of an object depends on the position of the object relative to the center of the earth. If an object is far away from the earth, then it will weigh less compared to when it's closer to the center of the earth, the center of the earth. So it depends, you can write, it decreases, I can say, it decreases with, in other words, the position of the object relative to the center of the earth. It means it decreases with increase. The weight decreases with increase in altitude. With increase in altitude. I've given examples of the weight of an object at sea level and at the mountain. I've given another example of the weight of an object at the sea level or on the mountain in relation to the moon. When you move to the moon, then the weight of an object, the force, which is the force or the pull towards the center of the earth, reduces as you move far away from the center of the earth. Can give another example. When you move further into the space, if you are to move further into the space, then you may be weightless, right? As you move further into space, you may find that you are weightless, because there is no gravitational pull towards the center of the earth as you move far away into space. So those are examples. So the weight of an object depends on the position of the object relative to the center of the object. This is not the case for mass. The mass of an object will be constant regardless of the position. Okay, whether it is in Jupiter or it's in the moon or on Earth, okay, it does not matter the position. Now, another factor that determines the weight of an object, number 2, you can write number 2, the mass of the object. The mass of the object. Remember, learners, we gave the formula for weight, and this mass is a function of weight. So we say that weight, which is measured in newtons, is equal to the mass of an object, which is measured in kilograms, times newtons per kilogram, times newtons per kilogram, newtons per kilogram. And we said that the force, this is kilograms times newtons per kilogram. We say that the force of gravity on the earth, the force of gravity on the earth is approximately 9.8 newtons per kilogram, newtons per kilogram. So if you want to calculate the weight of an object on the earth, you simply take the mass of that object in kilograms and multiply by 9.8 newtons per kilogram, newtons per kilogram. That will give you the weight. So weight here is a function of mass. So learners, that is the relationship between weight and mass, weight and mass, weight and mass. And I've said that the weight of an object in the moon is 6 times less than the weight of the same object here on the earth. So let's have some examples. Examples. An example here is that an astronaut has a mass of 57 kilograms. An astronaut has a weight of 57 kilograms. 57 kilograms. A, what is our weight on Earth? Example. Example 1. An astronaut has a mass of 57 kilograms. A, what is her weight on Earth? What is her weight on Earth? B, what is her weight on the moon? What is her weight on the Earth? B, what is her weight on the moon? Answer. Weight. We have seen, we have learned that weight, which is measured in newtons, is equal to mass in kilograms times the force of 9.8 kilograms per newton. That's the formula for weight. All right, it's equal to the mass in kilograms. This has to be in kilograms. If you are given this one in tons or grams, then first convert to kilograms, then multiply by 9.8 kilograms per newton. So with that formula, learners, we can answer the question, what is her weight on the Earth? What is her weight on the Earth? We have the formula here of weight is equal to mass times the surface gravity on the Earth, which is 9.8 kilograms per newton. So the question is, what is her weight on the Earth? So weight on the Earth, that is the surface, let me just write the surface gravity on the Earth is equal to 9.8 kilograms per newton. This is the surface gravity on the Earth. Because remember, weight varies depending on the position of the object in relation to the center of the Earth. So the weight then, the weight of a mass of 57 kilogram, the weight in newtons will be equal to the mass, which we are given 57 kilograms, times the surface gravity of the Earth of 9.8 kilograms per newton. Kilograms per newton. So this is the mass. Remember, this mass has to be in kilograms. If it's not in kilograms, then you convert to kilograms. You may be given mass in tons, in grams, and so on. So the answer here is 57 times, this is 57 times 9.8, 9.8, which is equal to 558.6, 558.6 newtons. That is the weight of the weight of a mass of 57 kilograms. Then B. What is her weight on the moon? What is her weight on the moon? Learners, remember we said that the weight of an object depends on two things. Number one is the position of the object in relation to the center of the earth. Number two, it depends on the mass of the object. Here we've calculated the weight of this object on the earth. We want to calculate the weight of the object on the moon. So what is the surface gravity on the moon? The surface gravity on the moon, remember I said is equal to 6 times less than the surface gravity of the earth, which is, in other words, a sixth of, is equal to a sixth of the surface gravity of the earth on the earth. The surface gravity on the moon is 1/6, a sixth of the surface gravity of the earth, which is 1/6 times 9.8 kilograms per Newton. So the weight of 57 kilograms on the moon, the weight in newtons will be equal to 1/6, okay, 1/6. Let me first have the mass. The mass is 557. The mass is 57 times the surface gravity on the moon, which is 1/6 times 9.8 kilograms per ton. So this will be equal to 57 times 9.8 divided by 6, which gives me here 93.1 newtons. 93.1 newtons. You can see the same mass of 57 kilograms weighs differently on the moon and on the earth. It is not the same. The weight of this body is a body of an astronaut. Okay, is a weight, the mass of an astronaut on the earth will weigh, okay, 558.6 newtons. The same mass of 57 kilograms will weigh 6 times less on the moon. So that will be 93.1 newtons. So learners, that will mark the end of our today's lesson, all right? The end of our today's lesson, where we sought to see the relationship between weight and mass. Okay, we've emphasized that the mass of an object is constant regardless of the position of the object, whether it is in the moon, it is in the sea, it is on top of a mountain, the mass will always be constant, but the weight of an object is not constant. Okay, it's not constant. And we say that it depends on two things. Number one, the position of that object in relation to the center of the earth. the center of the Earth. And we said also that the far you go away from the center of the Earth, the less the weight of that object. But if the object is closer to the center of the Earth, then the weight, which is a gravitational pull or gravitational force, becomes more. So we say that it decreases with increase in altitude. As you increase in altitude, then weight reduces. That means the gravitational force that is exerted on that object reduces as you increase in altitude, but it increases as you reduce in altitude. We gave examples of positions. Okay, we talked of an object that is at the sea level. The same object, if you are to place it at the top of a mountain, then the weight will not be the same. The weight at the sea level will be more than the weight of the same object at the mountain. What is the reason? The reason is weight is a force, is a pull. That pull increases as you move closer to the center of the Earth. I gave an example of this pen, all right? This pen. I say that if I was to surrender this pen to the force of gravity, then this pen will drop towards the center of the Earth. And in our today's lesson, we have gone further and did a few illustrations here. It's now your turn to practice. Remember, this lesson is not complete until you practice from the students' book. I'm giving you assignment. This is your today's assignment. Go and do exercise 15.2, questions 2 up to question 4, because we had done question number 1. Go and do question 2 up to question 4. Thank you, learners, for continuing to attend our tuition here at Manifested e-learning platform. Is our hope and prayer that you are gaining in mathematical skills. As you gain in mathematical skills, learners, we know that you are being equipped to make better decisions in everyday life. Thank you once again. Bye-bye.